Assalamualaikum and hi everyone. My name is AINUL ATHIRAH binti NUDIN. My metric number is H20203. Today I will present part A of business statistics, which is about the data arrangement, measure of central tendency, measure position and the shape of the data distribution. Before that, I want to explain the types of the data we use is group data, because a frequency distribution produced whenever observations are sorted into classes of more than one values. Total of the data is 672, but we just select the data random as much as 50 sample of set data. Discuss about the current price of bungalow for given size in Kuala Kerai, Kelantan. Data arrangement including class and frequency distribution, relative frequency distribution, and cumulative frequency distribution. Data can be described by using table and graph. According to distribution, we have followed the step. Constructing a frequency distribution is: first, decide on the number of classes. 2. Determine the class interval or width. Third, set the individual class limits. And the fourth, make the frequency for the class. The figure see the number of the data entries in the class and the frequency of the data. Next, we proceed with another step, is relative frequency. Relative frequency is the portion of percentage of the data that fall in that class. To find the relative frequency of a class, divide the frequency by the sample n. Last but not least, the cumulative frequency of a class is the sum of the frequency for that class and all previous classes. The cumulative frequency of the last class is equal to the sample. Second part, I would like to present about the measure of central tendency. The mean current price of bungalow for a given size was approximately 265,900 ringgit. The median is 266,700 ringgit, and the mode is the highest price of bungalow with given size is 269,700 ringgit. Next, measure of position.
Hello, I'm Wani. My name is Muhammad FAISAL ARIF ROSDI. My metric number is H20A1269. Today, I will present slide part A about graph. Histogram graph. You can see the most frequency persistence of the current price according to a particular size is the midpoint of size 289.8. There are RM15000 current price at the point, but at the least frequency of it is the midpoint of 213.8. There are RM4000 current price of the point. For the frequency polygon graph, you can see that the maximum frequency for the size is the midpoint of 318.3. There are RM50000 bungalows price at the point, but the least frequency is the midpoint of 223.3. There was a price of only RM5,000 at the point. Next, the measure of variation. A measure of variation is some parameter assumed to describe the amount of variation between random variables. The parameters that are used to quantify the amount of operation in a set of random variables. Is range, variance, a standard deviation. This a symbol for parameter. Okay, thank you.
Hello, my name is BAOYEE AMRAN. My metric number is H20A1113. In this part, which is part B, firstly, introducing to the data, and the second one is recognize the variable involved in the data. So, as a result, the sample set of data we use is from a secondary source, namely a data set from the internet, that is using this website as a source of information. So here is a sample of data we use to answer the first question and also to be a question for the next step. So the question we will use based on this sample is, does the arm span change based on a height? So through this sample of data, there are two variables, the arm span variable and the height variable. So we determine between these two, which one is the independent variable and dependent variable. First, we must understand between this variable. An independent variable can be described as the variable that is varied in experiment, while for the dependent variable is the variable that is affected by the dependent variable. Also, for the control variable are the variables that are kept constant in the experiment. As a result of the preceding explanation and experiment, the height to represent the independent variable on the x-axis, while for the arm span length to represent the dependent variable on the y-axis. Change to each of these dependent variable causes the dependent variable to change in the experiment. So that's all from me for the introduction to the data and the variable involved on the data. Thank you.
Hi, Assalamualaikum. My name is Muhammad RAFIQ FAHMI bin Abdul Rahman. My metric number is H20A1309, and I want to present part B, number 2. Based on the data below, the data set consists of X represent of 4 head centimeter and Y for arm span centimeter. The higher data was recorded for X is 152 for 4 times. The lowest data set record for X is 138 for 1 time. The data decrease maybe have a factor the arm span to head ratio approximately to be 1. The one area the femur to head was 4. This expected because on the average and over a large average, the human body has an arm span that is roughly equal to its head and femur bone, roughly a quarter of its head. For Y, the highest data set in arm span measurement in this experiment is 148 for 3 times recorded, and the lowest data is 138 for 1 time recorded. This is because the distance from the middle fingertip of the left hand to that of the right hand when stretching out both arms horizontally to the head. This ratio is approximately 1:1 ratio, meaning that a person's arm span is equal to their head. There are many more human body ratios. Some are independent of age and others change as we grow from a baby to an adult.
My name is Murugayah. My metric number is H20A1175. I'm gonna explain about the method of correlation, which is person's product moment correlations. This person's product moment correlation formula, the R represent for the person's correlation coefficient, the N represent for the number of observation, summation X, Y is represent for sum of the product X and Y, summation X square is represent of summation of squares of value of variable X, summation X in the square root in bracket it's represent for the square of the sum of all the values of variable X. It same goes to the summation Y as well. In this table can see the data for this assignment. The X represent for the independent variables and the Y is representing for the dependent variables. At the bottom there is a total for the summation X, Y, X square, Y square and XY. The information from the previous table and based on the person's product moment correlation formula, we got the answer. Based on the correlation strength, there is a very strong correlation at 0.917 between X and Y, which is the height in cm and arm span in cm, because the arm span changed based on the height. The higher the height, the wider the arm span.
Hello, Assalamualaikum. My name is SHAHIEDA binti Nikmud. My metric number is H2020344. Question 4 about develop the estimate regression equation. Then interpret the regression equation using this estimate. An estimate regression equation is contract Y estimate equal B0 plus B1x. So the formula for B1 is 1 equals summation X minus summation X minus summation Y divided by N divided summation X squares minus summation X squared of all the value of variable X per N. The value interpreted in the formula were calculated in question 3 included in the formula. B1 equal 420,275 minus 2943 minus 2854 divided by 20 divided by 433417 minus 2854 square divided by 20. So get the answer. B1 is 0.871. After getting the value of B1, can find the value of B0. The formula for B0 equal Y bar minus B1 X bar. Y bar and X bar are that's mean. So calculate the B1 equal 142.7 minus 0.871 multiply 147.15. Get the answer. B0 equal 14.533. The regression equation is Y estimate equal 14.533 plus 0.871x.
Hello, my name is ELLYANA Stephanie Anna Galang. My number metric is #20A1128. Okay, today I will continue with the last outcome and the conclusions in questions number 4. Okay, first I will talk the estimate regressions equations. The population's regressions line is estimated by Y equal B0 plus B1x. Okay, first BO is estimate for BO, the intercept. B1 is estimate for B1, that means slope of the line. And X is the value of the independent variable, and the Y is the predicted or estimated value of the dependent variable. Okay, the last outcome and the conclusions in questions number 4 is the regressions in questions is Y equal 14.53235 plus 0.871x. The equations crosses the y-axis at 14.53235 and the slope of the B1 is 0.871 and the last one is the constants of the B0 is 14.53235.